Hello everyone, welcome to my YouTube channel Decoder's Rain. So today we are going to see the how the construction of bistable and astable multivibrator is going to be happen using NOT gate. If you have not watched my previous video which that I have made on the multivibrators, which type of multivibrators are there like bistable, astable, monostable, these multivibrators are explained in our last video. If you have not gone through that, please go through that and come to this video. Then only you will come to know what exactly happening over here. Okay. So construction of bistable multivibrator using NOT gate. Using NOT gate. As we have seen in our last video, bistable multivibrator is having two states. It will be 1 or 0. In the both state, it is going to be stable. Okay. So this can be bistable multivibrator can be constructed can be constructed by using even number of NOT gate in a loop. Okay. So what this statement says, the bistable multivibrator can be constructed by using even number of NOT gates, okay, in a loop. Okay. We will see how this is going to construct a bistable multivibrator. Okay. Suppose this is a NOT gate and it is having a time delay. TD is a time delay. What is time delay? Time delay is nothing but the time taken by any gate after to generate its output after input is given. Okay. Hope you got this. The time taken by any gate to generate its output after the input is applied. What? Okay. So even number of NOT gates are used. Suppose 1, 2 NOT gate are used in a loop, and whatever the output of our second NOT gate, that should be given input to the first NOT gate. Okay. So this is a bistable multivibrator, and this is also having a TD as a time delay. But if you check output at this point, initially you have given input as 0. Suppose 0 as input you have given initially. Okay. And you are going to check output at this point. Suppose this is a Y1, this is a Y2. Not, and again Y1 is going to given as an input to the first NOT gate. So if you check state of Y, what is the state of Y? If you apply 0 over here, NOT of 0 is going to be 1. It is going to be 1. Okay. It's going to be 1. State of Y is going to be 1. Next, the 1 is going to give an input to the second NOT gate. If 1 is as input to the second NOT gate, it is going to generate 0 as our output. Okay. But if 1 is given input to the second NOT gate, it is going to give 0 as output. So Y1 is going to be 0. Y1 0 is a state. The same output Y1 is given input to the first NOT gate. If you given 0 as first NOT gate input, then it is going to generate 1 as output. That means if you see over here, there is no state change happening, right? We have given 0 as input and ultimately we got 0 over here. That means no any state is going to be changed. That means it means no any state is going to be changed. Okay. So this is how the construction of bistable multivibrator is going to be happen by using NOT gate. If you want to use OR gate, okay, so how the bistable multivibrator is going to be constructed using NOT gate as well as OR gate, or any gate which can you are supposed to use that can be used. We are using here OR gate, okay, OR gate and NOT gate. So the circuit will be like this is our first NOT gate having a TD as a time delay. This is our second NOT gate having TD as a time delay. This is our okay. This is our OR gate. Okay, and output the input. One of the input is given by our side only. That is 0. Okay, 0 is the input given to the OR gate. It's a OR. Don't think it is a AND. Okay, and the output of OR gate given as an input to the first NOT gate. Okay, suppose this state as Y1, this state as Y2, and this state as Y3, and same state Y1, same state is going to be written over here. Okay, if you check the state of this, suppose given input as 0 and leave the circuit to do its work by its own. Okay, given as 0, 0 is given as an input. If 0 is given as input, the state will be 0. Okay, state will be 0. Not of 0 is going to be 1. That means y1 is or y2 is at 1 and y1 is at 0. But then the next taken not of y2. Not of y2 is going to be y3. Not of y2 is nothing but 0. Okay. Next, it is given to the OR gate. OR gate is going to act as a like a plus b, right? Okay. So 0 plus 0. 0 plus 0 is going to be 0. So y1 is stable at 0. So next y1 is going to given input to the our first NOT gate. What? So it means if you see over here, there is no any state change at all at any at any position. We have seen your y1, y2, y3, y1. Here we have got y1 at 0 and same y1 we have applied as the initial state. Okay, so there is no any state change. So this is also a bistable multivibrator using NOT and OR gate. Hope this is clear to you all. If you want to generate bistable multivibrator using NOT and output AND gate, okay, so how this can be done? So suppose this is our NOT gate having TD as a time delay. This is another one NOT gate. It is also having TD as a time delay, and it is we have used a NOT gate. It is a NOT, okay, and one of the input is given as 1. It is by our side. We have given it as an input, okay, and the output of it given to the our first output of this is given to the our first NOT gate. What? Consider this one is as your y1, this is your y2, this is your y3, this is same as y1. Okay, so we'll see how this circuit is going to act as a bistable multivibrator. Okay, so initially you have given as 0. Suppose initially 0 is given and left circuit to do its work by its own. Okay, that means y1 is going to be 0. See over here. If ultimately we got y1 at 0, then it is bistable multivibrator. That is a concept that you should keep in your mind. Y1 is given as 0. The NOT of y1 means NOT of 0 is going to be 1. That means y2 has 1. But then NOT of y2 is going to be y3. Okay, NOT of y2 is going to be 0, right? It's going to be 0. And this is this is the AND gate. So and okay, or from my mistake. Y3 given input, one of the input to the AND gate, means 0.1. 0.1 is nothing but 0, right? 0. So ultimately we got Y1 as 0. If you check our initial Y1 and this is are same, this is going to be act as a bistable multivibrator. Bistable multivibrator. Okay. Hope you got what exactly bistable multivibrator and how it is going to be constructed. So now we are going to see a stable multivibrator. Okay. Next come here, a stable multivibrator. A stable multivibrator. A stable multivibrator, as name suggests, a stable. It is not going to be stable at one state. Okay, it will be if it is at 0. After some time, it is going to go to the one state. After some time, it is going to change its state and go to the 0. That means frequently it is going to be change its state without any triggering. If you not apply triggering as well, it is going to change its stable state. Okay, so how this can be constructed by using by using NOT gate. This can be constructed by using odd number of, keep that in mind, odd numbers of NOT. Okay, in a loop. Hope you got this. So we'll see what we have written over there. So odd number of NOT gate. Let's take example one NOT gate. Okay, for to understand. Suppose this is a NOT gate having time delay as TD, and this is its output given to the input to itself. But if you check the state, if you given 0 as the input to this NOT gate and let the circuit to work by its own, if you leave it as it is going to generate 1. Okay, next 1 is going to given an input to the itself. When it's going to be 1, the output is going to be 0. Then 0 is going to give an input to the itself. 0, 1. Okay, not of that 1. Again 1 is going to give an input to the same NOT gate. It is going to get 0. You can see over here, there is no any state is stable. Okay, that means it is frequently changing its state. So it is a stable multivibrator. Okay, hope you got this. Next, we are going to see how the frequency is going to be checked when we find the signal at this point. Suppose this is a Y1. Y1 we are getting signal, right? For some time it is going to be on, for some time it is going to be off. Okay, suppose TD is a time delay of our NOT gate. So what is the time period of its Y1? It is going to be on for TD. It is going to be on for TD. This is going to be 1. This is going to be off for TD. For this time period TD, it is on. For this time period TD, it is going to be off. Again, for TD duration, it is going to be on. For TD duration again, it is going to be off. Okay, like that it is keep on changing its state. Okay, so for one time period, when it is going to repeat its value after 2D, right? It's going to be 1 for TD, 0 for again next TD. Next TD it is going to change its state. For this time interval, it is going to be its time period. This whole is going to be its time period. We are representing it by capital T. So T equal to 2 TD. Okay, hope you got this. If you want to find its duty cycle, duty cycle is going to be for TD interval, it is going to be 1. Rest of it's going to be 0. Okay, so duty cycle, first of all, see what is duty cycle. Duty cycle is nothing but ratio of the time for which a ratio of the time for which the circuit giving output as y and the total time period. Okay, duty cycle is nothing but time for output is I divided by time, total time period. Okay, so for what time interval it is giving output as I for TD, right? TD, and what is your total time period? It is 2 TD. This 2 TD into 100 will give you in percentage. This will give you in fraction. Okay, this will give you in percentage. It will give you 50%. 100 by 2, TD will get cancelled. 100 by 2 will be 50%. This is the duty cycle of our stable multivibrator. For that, TD should be time delay. Okay, next one is we are going to see frequency. The frequency of circuit is given as F is equal to 1 by time period. Okay, what is your time period? It's 2 TD. 1 by 2 TD. This is our frequency of output. Hope you got this. Next, we are going to see how the stable multivibrator is going to be constructed by using NOT gate and OR gate. Okay, so we'll see construction of stable multivibrator. Construction of stable multivibrator using NOT gate and OR gate. Okay, we'll see that. First one, how the stable multivibrator is going to get when we use odd number of NOT gate, right? First of all, write odd number of NOT gate. This is our NOT gate, which is having, suppose we are taking TD1 as our time delay, TD1. Okay, next NOT gate is like having TD2 as a time delay. Third NOT gate is having TD3 as its time delay. Okay, and this input is given to our OR gate. Okay, got? Next, the one of the input of the OR gate is going to be grounded. That means it is going as 0 as input. Got? And next, the output of OR gate is going to be used as an input to the first NOT gate. And if you, this is our output Y. Hope you got this, and it is having its delay. Let's suppose TD4 is its delay of the OR gate. Hope you got this. And next we are going to find its frequency and output. Okay, whether we are going to check whether this is a stable multivibrator or not first. Okay, suppose we have given 0 as an input, so it will be taking value at 0. If you get 0 at this point output, then it is bistable multivibrator. If you get 1 as your output, then it is a stable multivibrator. That is the concept. Okay. 0. If you 0 given as the input to the NOT gate, it is going to produce 1 as its output. Next, NOT of 1 will be 0. Okay. NOT of 0 will be 1. 1 plus 0. OR is going to operate A plus B, right? 1 plus 0 is going to be 1. So see over here, ultimately we got 1 as output and given input as 0. So this is going to be act as a stable multivibrator. Got? So we are going to find its frequency. So to find its frequency, we want this time period. For what time period output is high? Got? So total time period is going to be T will be TD1 plus TD2 plus TD3 plus TD4. Okay, this is the total time period for which we are getting no, this is not total, this is into 2. Okay, this is a total time period for which our output is repeating. What? So how the frequency is going to be 1 upon time period T. Okay, the frequency will be 1 upon TD1 plus TD2 plus TD3 plus TD4 and into 2. This is the frequency of our circuit. Hope this video is clear to you all. If you are having any query related to this concept, you can post it into the comment section. We will happy to help you out. Thank you so much for watching the video.